The next question comes from the 2015 HSC and again is occurring midway through the paper at question 13b. Again, the question identifies for us that we're required to use our binomial expansion techniques on an expansion that contains two values of x to the power of 18. Here they have begun the expansion for us and named all of the coefficients of x as values of a. And the first question requires us to find an expression for a2, or the third term listed in this expansion above. This is a very similar question to the first question we looked at, but instead of requiring us to equate to a power of 0 for x, we need to equate to a power of 14. So by looking at the reference sheet, this time our value of n in our expansion is 18. Our a value is again 2x, and our b value, which is this time positive, which helps, is 1 on 3x. So we'll begin the same way as the last question by finding the general term using the formula where our combination is 18, choose k, multiplied with 2x to the power of 18 minus k times 1 on 3x to the power of k. Again, collecting our x values together and obtaining one power, we've got an x to the power of 18 minus k, a 1 to the power of k, and a 3x to the power of negative k using our index laws. So linking all of our like terms, our combination out the front, we have constants 2 to the 18 minus k and 3 to the negative k and a 1 to the k, and our x values 18 minus k and x to the minus k, and again creating one power by adding the powers together, we'll obtain our constant term. Considering that 1 to the power of k is still just 1, I'll omit that as it's not going to change our answer. And our power of x is 18 minus 2k. Now a2 occurs when x's power is 14, and so just considering our x values and equating their powers, we're looking to equate 18 minus 2k to 14. So equating the powers gives us our equation to solve, and will find for us that we're looking for the value of k at k equals 2. Now, as we're required just for the expression for a2, we don't need the x value on the end of that, we just want the coefficient in front of x. So I'm now going to substitute my k value of 2 into my general term, but I'm only going to put it into the parts at the front of the x value that are going to give me back that coefficient. So substituting it in, we have 18c2 times 2 to the power of 18 minus 2, so 16, times 3 to the power of negative k, so negative 2, And as it asks for an expression rather than a numerical value, it's fine for us to leave it in this combination format. We should use the notation that the reference sheet uses though. So we have 18 choose 2 times 2 to the power of 16 all over 3 to the power of 2. Part 2 requires us to find an expression. So again, we don't need to find the numerical answer, just the values that we are required to calculate. So we want an expression for the term that is independent of x. So this means that we're looking for a value in our expansion that doesn't contain an x value. So therefore, this question is exactly the same as the 2014 multiple choice question, where we're being asked to find the value of k that gives us back no x value, or x to the power of 0. So again, starting with our general term that we found in the first question, we have 18ck times 2 to the 18 minus k times 3 to the negative k, and our x values of 18 minus 2k. As before, our independent term occurs at x to the power of 0, and so equating our x values and looking at their powers, we obtain our value of k that gives us back our constant term. And so substituting this value of k into our expansion formula, we'll obtain the expression that will calculate the constant term. And considering that the constant term is independent of x, we don't need to write the x values for it. But we will simplify it and we will use the notation listed on the reference sheet. So the constant term would be calculated by 18 choose 9 times 2 to the power of 9, all divided by 3 to the power of 9, and giving us our required expression.